Flavio Adamo, which is Italian like me, but I am more Sicilian than Italian, but I am partially Italian. You can have multiple identities. Says, hello everyone, I am the creator of the comparison video between O3 Mini and DeepSeek R1, which is currently going viral on the internet. And he says that other people basically posted the video without giving credit, which it's unfortunate. I think that giving credit is great, but I don't care about these questions that I have. I just want to analyze why these kind of benchmarks are totally useless. So whoever the credit is, they are useless. And I will show you. For starters, here the idea is that the R1 implementation is terrible and the O1 O3 Mini implementation is good, which is not the case. The O3 Mini implementation is better, but as you can see, the ball arrives almost to be completely orthogonal to the floor and still is not going anywhere. So both are broken. Closing this. But it's not much if one is better than the other. For example, they tested these two, but if I run the simulation I obtained with Sonnet, this is the first one that works. So that's what should happen. Okay, it's less spectacular because it works, so the ball follows the hexagon, and if you want it to be... Also, Sonnet provided a very clean implementation with clean classes. It's amazing. And let's use the restitution of 1, for example. It becomes nicer to look at, but it's the same thing. And this is a much better implementation, no? So it's not like that chain of thoughts is the only consideration that we have to evaluate if large language models work or not. There are problems where it is very important, and this is, to be honest, one of them, but still we are at a stage where models not doing much chain of thoughts, doing just a limited chain of thoughts, like Claude Sonnet, can perform better. But still, the point of this video is that anyway, these kind of comparisons are useless, and I will show you. To start, since a bit of culture of computer science will not be a problem, I guess, here what we are trying to do is to understand if a line and a ball are colliding. What you do in this case is to find the perpendicular of the line passing from the center of the ball, and if the distance between the crossing point with the line, the distance between this point and this point is more or less the radius, this distance here, the radius of the sphere, then there is contact. And then based on the vector, on the velocity vector of the ball, you calculate the new velocity. If instead you had two balls and you want to understand if they are colliding or not, you take the two centers, use the distance formula that will be like this, and the two components x2 minus x1 squared plus the y2 minus y1. Okay, so it's super easy. So you get this distance here, and what you do is to check if this distance is more or less the sum of the two radiuses. The first radius and the second radius summed. Then if it's between a given epsilon, the spheres are colliding. If it is greater than the sum, the spheres are apart. If it is less than the sum of the radius, the spheres are one inside the other. Okay. This is trivial geometry, but it is useful in order to understand what you are asking the model to do. And after you understand if two spheres are colliding, like this and this one are colliding, based on their normal, basically, you decompose, if this is the, I don't know, the velocity vector of this sphere, you decompose it in two components. One is perpendicular and one parallel to the segment connecting the two centers, and you just use basically the parallel component is what will change the velocity between the two, and the orthogonal one is completely irrelevant. And you can easily see this if you imagine two spheres. This is this velocity vector. This is this kind of velocity vector. Here we will have the normal. And even if they are barely touching, no transfer will happen of motion because there is no parallel component. Okay. So yesterday was at least okay with my cough. So I thought, okay, let's go out in Catania and stay in the balcony, seeing the fireworks and the Sant'Agata festivities, and drink wine, and now I am fucked again. But I deserve it. I deserve much worse, I believe, but anyway. So that's what we are asking the model to do. And moreover, there is a problem. Doing this test, or this kind of test, just once, it's very unlikely to produce the same result, because the temperature of the model is greater than 0. So sometimes it will write an implementation, sometimes it will write another implementation. However, I tried to implement it again with R1, and for example, this is much worse than obtained by Flavio Adamo. Flavio, I'm giving you full credits. Or I tried with V3 vanilla, and it kind of works for a second, but it's not worse than the R1. So what I thought was, it's already very limited as a test, and you can believe maybe perhaps it's limited, but still this allows me to understand if the model is good at doing this basic geometry checks, and to understand how to write the equations, the mathematical formulas in order to detect collisions and in order to detect the dune velocity. But it's never, not even that. So look at what I did. I wrote another similar prompt, a bit more complex in some way. Write a Python program that shows a configurable number of balls bouncing inside a box. So multiple balls. The ball should be affected by gravity and friction. The program should detect collisions both with the box and among the balls. the balls will be of different sizes, and the bigger the ball, the greater its mass, and this should play a role with balls interact. Why I wrote this? Let's silence this fucking phone. I wrote this because when the balls are exactly the same, as I shown you, basically you can just transfer the perpendicular forces between the two. Instead, if the masses are different, you have to exchange proportionally to the masses. So I asked the Sonnet to do that, and task 2, Sonnet. The result is that also it thought it was fun to let me click, and as you can see, it's not working very well. You see here, they are like attracted. It's completely unrealistic. There is some error of some kind. I think I even tried to tell him that there was something wrong. There is something wrong when recalculating the velocity vector after the two-bolt collision, because the effect was different in the first version. Force is added from thin air for some reason, since balls accelerate a lot when colliding. So I wrote a new version, which is the one that I shown you. Now this first bug is no longer there, but still it doesn't work. So I tried to what should be the winning model according to the test we did, the prompt that Flavio wrote. O3 mini should be the best, right? I also used the O3 mini high, so the one that thinks a lot. Let's check. It's completely wrong, as you can see. Doesn't work. And instead, guess what? R1 wrote the only correct implementation of that. So it's the same domain, the same kind of problems, the same language, the same domain that where it looked like O3 mini had an edge, and now instead Sonnet, even if it's very powerful, cannot nail it. O3 mini can't, and R1 is working very well. It's very nice. This kind of simulations, I did them a lot when I was learning to program. It's a lot of fun. Also, it's a great way to show, especially to young programmers, why it is important to know some mathematics. Oh, mathematics is boring. I don't need to know mathematics. I just can code. But without mathematics, you cannot do a lot of things, a lot of cool things. You cannot do shading, ray tracing, 2D simulations. So, all this to say that I believe you either should do some testing, like test the model for 2-3 days with many different problems against another model, and take a score matrix or something like that, and then you did a private and limit evaluation of the model, but you did something, but just throwing the first prompt that crosses your mind. Also, I will be very curious to know if just using a different prompt would produce a better result. Because if you check this prompt, it's the kind of prompt you would use in image diffusion models in order to create an image. Stay focused on the exact wording Flavio used. Write a Python program that shows a ball bouncing inside a spinning hexagon. The ball should be affected by gravity and friction, and it must bounce off the rotating walls realistically. It's a prompt more for a diffusion model. There are not enough clues. I would write like represent the hexagon as a number of segments, then implement functions in order to find the collision between the ball and the segment, and so forth, to give maybe a bit more context. Probably reasoning models should be able to rewrite the prompt in order to be more adapt, but still they fail sometimes. But anyway, it's better to use to write a coding prompt, not like you are imagining what you see in the screen, but in more implementation near terms, assuming you have of course some idea about how it should work in the implementation side. Okay, just to say, if you want to benchmark, be prepared to do a lot of work, a lot of hard work. Otherwise, the results are funny to show. It's nice, interesting to see what these models. Well, you know, even these two failures are a testimony to the fact that these new LLMs are very, very strong, are very great from certain point of views, because you can easily like take this implementation and then start with a model to say, let me show how you implemented collision detection, how the force was transferred, and you get to the point that the implementation is great. It's not a super easy task, it's not very complicated as well, but in general these models are making progresses.